So hi everybody, welcome to the Information Reliability Service presentation. I'm going to talk about a novel approach to fraud detection. Small provocation to start. Fighting frauds, it's like playing slot machines. What do you think? No worries, the Swiss Post is not starting an online casino. We're not doing gambling. But with an algorithm which has some analogies to slot machines, we turn data into a weapon against the digital crime. So my name is Giovanni Degiorgi. I'm glad to be here. I'm solution architect at the Swiss Post. And today I will guide you through our solution to fight the frauds in the Swiss Post. Quick side information before starting and jumping into the topic. This presentation is part of my master thesis that I did in SUPSI last year, and is also part of my daily business because we are doing that in the Swiss Post, so I'm working on that as well. And the project is called IRIS. Here you can also find some information about me. I'm not going to bother you about my age and kids. If you want to connect, feel free to do that. Maybe you can wait till the end of the presentation. If you think it is good, you can connect, otherwise not. Up to you. So moving forward, some facts and figures about Swiss Post, very important. The Swiss Post is a major logistic provider in Switzerland. How many of you know Swiss Post? Stupid question. Maybe, who doesn't know Swiss Post? Okay, this is good. Maybe more important, who knows machine learning? All of you? Okay, it's great. How many of you are using that in production? Machine learning? Okay. So here's some facts and figures. Sorry, I just went out of context. Presentation is going to blow up probably. As you can see, we are transporting a lot of parcel and letters. So we are talking about millions and billions. We have also a lot of customers which are registered to our online portal and our application. This data is actually quite old, as 2022, so this is probably much higher than that. So we are also offering support to 4 million of households, so we are serving them every day. And we are also serving the boxes, the yellow boxes that you can see all around, so which are called empty boxes, and so on. So it's a quite stunning statistics, and all of that is good and nice, but there are some threats. So quick information about the threats that we have in the online space and that we are also seeing as Swiss Post. The phishing rate is growing. I'm not going to bore you about the numbers, but just to show that it's always increasing, also between 23 and 24. The data theft is also growing, as you can imagine. Selling of identities and so on is also blowing. The e-commerce portals are one of the most attacked platforms. And of course, yeah, so we have also online portals. Ad hoc tools are proliferating, so there are a lot of tools which are growing for the fraudster community. And as we saw today morning in the speech, in the keynote, AI is a fantastic accelerator of speed and efficiency for positive and negative. So you can also use that for doing frauds. Of course, don't do that at home. So, but how does it affect the Swiss Post activities of that? In the Swiss Post, it's mainly performed on our platform with fake accounts. They also do use fake addresses. And such criminal activities, it's quite costly. So for us, around 5 million Swiss francs annually, which is a cost, is not the cost of goods, but it's a general cost about losing credibility and so on. So to the other side, the cybercrime is becoming, as I said, sophisticated and organized. And therefore, we are investing a lot to fight it. But how to solve this challenge? And in 2023, we started a project called IRIS, Information Reliability Service, with the intention, based on customer data, to calculate a trust score for every address. So a trust score basically goes from 0 to 100, typically, where an example, 90 is good, 20 is bad. Quite simple. And it will be used specifically for some activation flow. This is the idea. And how is it calculated, this trust score? The trust score is a weighted sum between different sources, between different scores of sources. And one of these sources is provided by a machine learning algorithm. So it's a model. As I said, the trust score in the future will be used for several scenarios. For example, the custom verification process. And talking about the process, how does it exactly work, the verification process? Starting from the flow, starting from the left-hand side, going to the right, of course, quickly through it. The customer creates a Swiss sign ID. Then it will add to this Swiss sign ID an address. This address is verified by our services, so we know if it's a valid or not, valid in the sense of plausible. And then the data is passed to the trust score, where we calculate if it is good or not good. And depending on that, so if it is a good trust score for the customer, it goes to the fully digital identification and verification flow. At this point, he has a valid address, high trust score, and the identity is verified. So once you are through all these steps, of course, you can act and work and do whatever you want on the portals. So now we are going to focus on the innovative part of, right, what you are probably most interested on, which is the machine learning model. So the proposed approach was to classify the addresses. The proposed approach is a multi-armed bandit algorithm, which is a probabilistic learning algorithm, as you can read, that adapts the strategy based on real-time feedback. So you can always give feedback to it and always train it again. And performs well in limited information scenarios. We will see later what is that the idea of limited information. And is also capable of continuous learning and as an adaptive approach, depending and adjust the balance depending on the strategy between exploitation and exploration, which is very important. To understand what is that exactly, a practical explanation of what is a multi-armed bandit algorithm. Imagine that you are in a casino, you enter in a casino in front of you, like here in Lugano. You have a row of slot machines. And now, since you're going to the casino probably because you want to win, the idea is that you maximize the reward. So you're in the casino, and what is the best slot machine that you have to play? This is basically what the multi-armed bandit is doing. At the beginning, is not able to know which is the best slot machines to pull the lever. But after training, after doing some probes, is able to understand which is the one which is paying out more. So of course, the goal is that you don't lose the money, and the analogy to the fraud is that you don't lose the money because of the frauds, so you're able to discover the frauds. So basically, multi-armed bandit, it's an algorithm which is able to find which is the best reward that you could get out of, in this case, a lever pool. So, but let's go deeper into the anatomy of the multi-armed bandit. So multi-armed bandit is always represented as an octopus because he has multi-armed. So it has multiple arms, right? And of course, he needs a bandana because he's a bandit. And so the arms, you have the arms, of course, what I said, which are the actions. These are basically different choices that you can have in your algorithm. And in the classic slot machine analogy, what I said before, you basically have two arms. For every arm, you have a reward distribution, which is a function representing how much you can get for this action, so the reward for a specific action. Then you have the agent, which is a decision maker, and selects the arms and receives the rewards. You have also the dilemma between exploration and exploitation. It's also important that in a model, you have a good trade-off for these two parts to avoid that you're stuck in a minimal situation. And you have the reward function, which is the payoff for a specific action that you're doing. The regret is basically the difference between the action that you performed and the optimal action for a specific analysis. And last but not least, you have the context. So in Multi-Armed Bandit, you have also to provide a context, which can be different. For example, in the case of parcels, you could give the value of a parcel. But to train a model, of course, we need the data collection, because without data, we are stuck, right? So the data is the core of everything. And here we have a list of data that we used in the Swiss Post for the training. You see between addresses, parcels, and letters. This is not so much important. The most important part is actually that all these data are in different technology, different database. They are on-prem, they are off-prem. Yeah, we have also file systems. So we have different, let's say, scenarios and situations. So they are segmented locally. They are also segmented in different technologies. And how to access all of them. Probably you're thinking to copy them locally, right? So don't do that. I wanted to put a slide, but it was a bit too aggressive. So don't copy the data, especially the productive data on the local machine. So how to access them? To our help, it comes the enterprise data governance. And how many of you have heard already enterprise data governance as a word? 1, 2, 3, 4, 5, 6. Okay, but you don't count because you're working in the Swiss Post. So just 3. So it's of course something that is not easy to implement, and is not easy also to sell to the business. But it's basically, so the challenge, as you can imagine, is to get the data for the training of the model. And in the enterprise, everybody has his own cluster, his own data, and it's difficult to get them. Nobody wants to share the information. Nobody wants that you get their data, especially if you have a big company. This is very important. So it's difficult to get the data, basically. So what we did in Swiss Post is to create the concept of data room, which is quite interesting. So think about the data like books or shelves of a library. And then if you want to do some specific action or something, you want to train some specific model, you create, so you have your library, then you create the different rooms. And in the rooms, you put the specific data that you need for the training. So you can basically isolate what you need for your specific training. What is, of course, the positive thing about that is that you can do anonymization, you can do just have the important features or data that you need for a specific case, and you don't have all the data, right? So how we solve this? Of course, this is for compliance with regulation. And how we solve that? With AWS platform that came to our help. We set up a flow to copy the data. Basically, the idea is that you have different sources. We have Kafka, we have Postgre, we have Oracle, we have all the data sources. And we can copy them with Amazon Glue and move them on S3. So on S3, we can copy all the information as static files. And then with the help of Athena, you are able to do SQL-like queries. So you can basically perform queries like on a DB, but it's on AWS. So the data is never leaving AWS, it's never leaving the cloud. And then, and then you can do the machine learn on Amazon SageMaker. So in SageMaker, you can connect to Athena and get the information and the dataset that you need for your training purposes. So moving forward, a bit of insight about the data selection and classification, because first thing first, you have to create a target class for your model. You need to know what you are looking for. And what we are looking for is fraud, is non-fraud. Oh, sorry. And to understand which data to use, because of course in the Swiss Post we don't have a flag which says fraud, non-fraud. So you have basically to understand it out of the data. So we analyze the fraud process, which is starting by a notification event. So the fraud experts are getting a notification event. Then they find a specific profile. They put some comments. And according to the comments that we are getting on the DB, basically, we can say if something is possible fraud and if something is not a fraud. What is also challenging is that if something is not marked as a fraud, if a transaction is not marked as a fraud, it doesn't mean that it's not a fraud. So it could even be that you have a fraud going on, but nobody knows, just to say. OK, now we have our data set because we are able to distinguish between the class of fraud. So we know if it is fraud or not fraud. I want just to give some insight about the data. It's very important to understand those dimensions. So as I said, different data sources. We just kept a time frame of 3 months. And now probably you are thinking, why just 3 months? Because SwissPost is not 3 months old, right? So SwissPost is existing since 175 years more. So we could use all the data, right? We're not using all the data, of course, because the data are expiring. So the situation that was 4 months ago, maybe nowadays, now is obsolete, so it's already outdated. So you have also to pick the right time frame when you're doing the analysis. We had, so we have 72 features and around 10,000 fraud cases out of 12 million non-frauders, so non-fraud cases. You can see it's the ratio is super unbalanced, right? And the volume is around 40 gigabytes for these 3 months, and it's changing, of course, daily because we get data constantly. Every day, the glue job is running through the applications, getting the data, publishing the data on S3, so we can train the algorithm every day. What is the most important part of this slide? We have a very unbalanced data set. This is the biggest problem that we faced in this project. So to solve this, because of course the data that we had were not only not clean or not prepared, but we wanted also to enhance them, so to create new data. So we created data out of the postcode, we created data out of the dimension of the parcels, so calculating the volume. We did also one-hot encoding on the categorical data. Categorical data are like the postcode, as I said. So we created that for the different regions in Switzerland. So we have 6 regions, and we also did for the cantons, and so on. This only to increase the data set and have better performance, of course, of the model. So generally, in the fraud, it's well known to have an unbalanced data set. So if you ask a data scientist, he will say, you're doing fraud, oh, you will have a problem because the data set usually, you have few frauds. So nobody's expecting 50-50 frauds, non-fraud, of course. This is not expectation. Also because if you run like that, the business will die in a few days. So as I said, our data set is unbalanced too, as the others. So we had to mitigate this. And what we did is to apply undersampling of the non-fraud, which basically means taking just a part of them, not all of them, and oversampling of the fraud cases. So you're basically using the fraud cases multiple times. Think about a huge list of fraud and a small list of frauds, and then you take a piece of this and a piece of that, put together, train. Then you take always this piece, and you combine. Like that, you can have multiple data sets, you can increase your data set, and of course, train your model. This is the idea, and get better performance. There are also other possibilities to do that. You can do synthetic data with the risk of having some strange situations. We saw today morning. You can also apply Smoothie, which is an algorithm to create also synthetic data in oversampling technique. So there are plenty of techniques for that. Another important point, it's related to reward engineering. Now we have examined all our data set. We know the data, we know the dimension, we know the time frame, we know everything. But how to say the model, how to say the multi-armed bandit, you are performing well, you are going in the right direction, you are not going in the right direction. And what is the right direction? Who knows what is the best decision? So to our help, it comes the reward engineering. So in the reward engineering, basically, you are telling through the cost matrix what is the reward for a specific estimate. So, for example, we can see if the algorithm is finding a fraud, so if we have a true positive, so the algorithm is saying it's fraud, and it was a fraud, it's a fraud, then we are giving 100. If the algorithm is saying it's not fraud and it's not fraud, true, negative, it is 1. And then, of course, we can penalize. So we can say, the trick here is actually that we are penalizing the algorithm, saying, if you are doing something wrong, we are taking out of you the points, right? So if you think about money, could be think about dollars, but it's just a pointing system, basically. And the reward is just a score. It's a number, right? So if you are saying that, for example, it's a non-fraud, but it's a fraud, then we are basically saying minus 60. So this error count more than this error, like double. Meaning that we don't want the algorithm to do errors. So to pick, better to say that it's not a fraud. And this is the way basically that you are telling the algorithm, hey, come on, be aware, we are putting attention on finding the frauds, but not skipping a possible fraud. Last but not least, the strategy selection. What is that? So we picked the linear upper confidence bound algorithm, LinUCB, which is actually better to say. What is that? Sorry, it's a bit technical. But this is basically very handy if you are trying to do this is the strategy to do the selection of the arm, right? So here we are an example of 3 possible arms. Okay, so we have 3 possible actions that we can do. And what you see in green is the mean reward that we got over the time, right? And now, if you're thinking about, let's get the maximum reward out of it, which of these 3 arms would you pick if you know that this is the mean reward over the time? Any idea? If you want to maximize, so you know that this is returning this, of course, this is the mean reward. Higher is better, lower is worse. This is returning, let's say, over the time 1, this is returning 2, and this is returning 3. If I want to maximize this, which arm would you pick? Correct, number 3. With the risk, of course, that you're always selecting number 3, also because you're always picking number 3, right? So this is the risk. And the strategy is actually saying, if I see, okay, that I have the confidence, so it's, it is very confident that I'm going to remain in this interval, so I'm confident that I'm not going out of this. So the dashed line are basically saying, even if it goes well, you go 3.1, right? But this one says you have more confidence, so you can even get higher than this one, right? Possibly. So what it does, the algorithm, it does exploration. So it says, you know what? I take arm 2. Because even if the mean is lower, I have the possibility to get a better reward. So there is the possibility to get better. And this is the strategy. So looking at the time, okay. So here's some information about the experiment. Of course, it's not only theory. We use that. We practice that. It was actually a long road to build it. And what you see is the initial result, what I got out of SageMaker. So with the print of the graph, you see here the cumulative reward, which is going down. What do you think? Is it positive or negative? Is something that you were expecting as a data scientist? Or if you would implement something to, let's say, if the points are money, and this is your bank account, is it good or not? So you want to have it, it's cumulative, meaning that over the steps is going down. If it will be a stock market, probably you won't invest in that, right? If it will be, also the profit of some companies, I wouldn't invest on that, right? So the cumulative reward is actually saying the trend, if you are getting better or not. And this is actually the way that we can estimate if the algorithm is performing well or not. And of course, as you can see, this is a false start, right? This is not good. So we are not expecting that. We don't want that. So, and after fixing the reward function with different values, this is exactly what we saw before. So we change and we force to have more, let's say, aggressive values with grid search, but it's more complex. We got something like that. So the cumulative reward, which is in blue, is growing up. It's good, okay? But now, as a data scientist or as an engineer, you could think, yeah, listen, Joe. I mean, maybe if I do a coin toss, it's better than your choice, right? Because who knows? I mean, if I take if every action I do like 50-50, maybe it's better because, or even worse, or even more aggressive. Since the data set is very unbalanced, why don't you do just a comparison between an agent which is always returning fraud? So you compare your agent against something that is always saying fraud, because saying always fraud is 99% true, right? It's 99% correct. So we did also that. And so we did a comparison between a random agent saying always fraud, and the MAB outperforms it. So it's much better.
Can you explain how you ended up with that numbers? I mean, how do you decide the rewards?
This one?
Yes.
This is done with grid search. So you can do a grid search, and out of that, it will try the difference. So you can do an interval for the values to create basically, and we will try all the possibilities. So we'll run the model with all the possibility, and then you have also libraries in Python that does that for you in different way with different strategies also, okay. And that is basically out of it. But if you run it twice, it will give another value because always trying different solutions. So it's never the same. But of course, what you can extract out of it is that you have to push on that. So you have to force the multi-armed bandit to be very aggressive on the search of fraud. And now we will see what is the drawback of that, because there is, of course, a drawback. So to jump and to explain the results, sorry, I need to have some technical or some more theory stuff. As we saw before, the cost matrix, here you have a confusion matrix. Exactly the same. The confusion matrix is just the situation when you have negative, actually is negative, you predict negative, is a true negative. When the actually is positive and you predict positive, it's a true positive. While you have, for example, this was actually quite common during the COVID. If it actually is negative and you predict positive, it's a false positive. So you're predicting positive even not. And vice versa, you have false negative. Why introducing that? Because out of the algorithm, sorry, it's a bit difficult to read probably from the end of the room, you can see the situation. So the algorithm is predicting over 26 fraud cases, is predicting 25 correctly, one not correctly. Meaning that one fraud, so it's a false negative, saying it's not a fraud while it's a fraud. And as you can see on top, the true negative are around the half of it, while we have also false positive. So we are saying that non-fraud are fraud. So you see here the cons of being very aggressive on setting the fraud, because the algorithm will also say that something is fraud, even not fraud. But this is very common. So in when you do fraud detection, you prefer to be, let's say, conservative. You prefer to say it's a fraud, do an additional step, perform an additional process, then saying, oh no, it's all good, go ahead. So it's like when you do a clinical trial. If you say you are not sick, you are really not sick. But if saying you are sick, it could be that you're not sick. It's basically the same. So the precision is bad because, of course, of that. You have a lot of false positive. But the recall, which is most important for the fraud detection, is very high, meaning that 96% of our cases, fraud cases, are identified. So very few fraud cases are passing through. The F1 score, of course, which is the harmonic mean between the two values, is not so good, but this is not relevant for us. What we aim to have is a good recall. The practical application. So we are implementing the model in 2025, should go live end of this month. It's going to be integrated in other business customer processes. And it's going also to be used by My Consignment, which is an application that we have in production. So it's going to be used for the verification flow at the beginning. Key takeaways. The multi-armed bandit is actually learning out of our data, which was probably the biggest question, because you never know that it's working or not. Data collection in large enterprises. They involve, I tell you, complex processes and legal, and it's annoying. Don't give up if you're starting that. The data is never ready for your use, so don't expect it to be ready. If you're producing data, maybe my suggestion, try to make it as clean as possible to avoid that you have to scream like a baby if you have to clean it, because I did. Working in the cloud, because we are working in the cloud, so we don't want to have data locally. We are prohibiting that in the Swiss Post. It's feasible, and it's actually also funny. With SageMaker, it's improving and moving very fast in the cloud. So if you have experience with AWS, for me, SageMaker API is really nice. It's cool. And you don't have the problem with Python version, what I have to install, Conda contracts, and so on. It's all online, so you have just to connect and use. Be patient, and the result will come. I can just tell that. Thank you for your attention, and if you have any question. We have a booth. Yes?
Thank you. What about the transparency, the auditability of this result? I mean, for all the false positive, did you try to figure out why the system was making this mistake, try to correct him, try to give an explanation in general of what's going on? Even I believe you maybe need to contact a customer and ask for additional information, say probably
Yes.
you are doing something wrong, and maybe you need to give an explanation when you do this, right?
That's the idea. That's the idea. But basically, think that what is behind that is, if you are marked as a let's say, if the trust score is, I would say like that, if the trust score is not good, because this is the point, it's not fraud or not fraud. So if the trust score is low, you are not able to do the full digital flow. If the trust score is good, you can do that. So you have a seamless verification flow, which is important, right? Because the customer nowadays, I had also a slide for that, but because of time, I didn't present that. Of course, the customer nowadays expecting to start something and finish the same day, not waiting for an activation ladder. In the Swiss Post nowadays, we are doing the activation via ladder. So if you're not, let's say, trustfully, you get the ladder at home. So this is the fallback scenario. Of course, we want to get rid of that, and then in that case, we will also have to contact the customer to understand why. But yes. Think about that. You have a lot of customers which are moving around Switzerland. So you have also people, moving the ladder. So the data are moving quite fast.
Okay, but the main question is, when you have a score, it's just a score, or do we have a ways to track, to understand why that score is so low, is not...
We don't track the score because it's not permitted. So we can just calculate on the fly because we cannot do profiling of the customers. And actually the data is, all the data is anonymous. So I don't know the name. I just know that this specific address is not good, or is even not good. The trust score is bad or good. And of course, the interpretation of the trust score is also delegated to the who is using the service. This is as a service. So we call the platform, you will get 60 back, for example. You can decide, for me it's good. Or you can get back 20 and say, for me 20 as a trust score is good. And then somebody else can say, no, for me it has to be 100, right? It's never going to happen probably, but yes. So the threshold for you to say good or bad is not...
It depends on the service.
Exactly.
Hello, thank you for the presentation. Just one question. Have you calculated the return of the investment of this solution?
No, honestly, no. No. Yeah, for me, yeah. I did that for a master, so I closed it. No, of course, if we can avoid to send the ladders, we can spare money, yeah. But we have to do some statistic before, yes. Yeah. Yeah, of course. Of course. It is difficult to calculate the return also because it's not everything goods or value per se. So it's not objective. Also, having the customer which is satisfied, which is actually one of our main goal, it's very important, but you cannot calculate that. How you calculate? You know that the customer is complaining less. Usually the customer are complaining. They're not saying, hey, thank you for the great job. So how you can calculate that? I mean, if you get less complaints, we can say we have probably more streamlined and, let's say, seamless activation flow. Yes. We can spare on the ladders. Yes. But now I cannot really estimate how much. So if you have any other question, feel free to come to the booth. We have the booth. We have also open positions. It's not only machine learning, so we do also other stuff. Yeah, I'm over. Thank you very much.